Hello everyone. So we'll be discussing the Leetcode weekly contest for today. The contest number is 376 and the date today is 17th of December when I'll be uploading this video. So yeah, it was a decent contest. We had a vague problem in problem number 3, which I didn't really like personally. So but still, I'll be discussing all the problems and I'll be showing you the codes for a few of them. If you want the codes for all the problems, you can contact me through LinkedIn or yeah, probably on LinkedIn as well. So let's begin with the problem statement. So firstly, let me just open all of them in separate tabs so that we can discuss that. So we'll start with the first problem. In the first problem, we have been given a 2D integer matrix grid. Size is n cross n. So again, it's a square matrix. All the values in the matrix will range from 1 to n square. Each integer appears exactly once, except a, which appears twice, and b, which is missing. Okay, that's interesting. So what we have been given is that in this question, there's a square grid of size n cross n, and all the elements are in the range 1 to n square. And one integer appears twice, and one integer is missing out of that range 1 to n square. One value is missing from this matrix, and one of the values is repeating twice. So let's see what we need to do with these values. Okay, we just need to find the repeating and the missing numbers. All right, and we need to return the answer in form of an array. So the first index of our answer array will store that twice appearing value, and the second index, that is the first index precisely, that will be storing the missing value. Okay, that's all we need to do. So if I just take this example 1322, okay, that's our sample case. So the size is 2 cross 2. So the value of n here will be 2. So the range would become 1 to 2 square, that is 1 to 4. Out of all the values we see, 2 is appearing twice. So the value of a will be equal to 2. And the missing value which I can see is that is 4. 4 is not present in this matrix. So yeah, that is what we'll be returning. We'll be returning 2 comma 4 as the answer. Okay, similarly for the second matrix. So it's a pretty simple problem. I don't feel like a code will be needed for this. So I'll just probably explain this on the whiteboard. Okay. What we can do here is that we can have a map slash array, 1D array precisely, data structure for storing the frequencies of all the values. So what I can do is I iterate over my matrix. Okay. That will be in a for loop. Okay. For I is equals to 1 till n, or j is equals to 1 till n. What I'll do is I'll store, let's say my map is MP or my array is AR. Okay. So I know what is if I'm declaring the array. So I know what will be the size of this array. The size will be n square plus 1 because I need to store the frequencies of all the values from 1 till n square. So the size will be n square plus 1, right? So if I'm going for the array, and again, when I just declare this array, all the values should be 0 initially at all the indexes. So I'll just take my x value, x is equals to that matrix I of j. I'll just take this value and I'll increment the count. I'll just do array of x plus plus. Okay, that's all I need to do. Okay, this is my main logic. Okay, after that, I just need to create a for loop separately from iterating from 1 till n square, and I just need to check if array of I, let's say the variable here is I, is equals to 0. If any variable is equal to 0, I know that number is my missing number, so I'll mark it as B. Okay. And if the frequency of any element is equals to 2, so I know that is my A value. Okay. So I just mark A as I in that case. Okay. I just do an else if here. Okay. And yes, I think These two parts will make up my solution. Now, when I have my values for A and B, so the last step which is left is just to push these values in the final array. So my final array is, let's say, answer, empty array, pushback. PB is a pushback. I'm just writing it as in a short form. Okay, answer.pb, A, answer.pb, B, and we'll just return this value. Okay, I'll just return answer. Simple as that. So this finishes the first problem. Now we'll move on to the next problem. I hope this was clear to everyone. Yeah, just to specify, the complexity for this code will be, in worst case, that will be n square, because I'm iterating over the matrix n, that is a nested for loop. So the worst case complexity would be n square. And this again, we are iterating from 1 to n square. So yeah, this is my time complexity over n square, worst case scenario, right? Let's probably add a new page for the problem 2. Okay. Problem 2 was also a decent problem. I would say fairly simple, but again, it's difficult as compared to the first one because it's a medium category one. But if you just think about it, it's not that difficult. Let's firstly go through this. Okay. So we have been given an integer array nums of size n and a positive integer k. Okay, we have a 1D array and an integer k. We divide the array into one or more subarrays of size 3, satisfying the following condition. So we have been given two conditions here. The first condition is that each element of nums should be in exactly one array. All right. That means we cannot add one particular element in more than one array. That's what it means. Okay. The difference between any two elements in one array is less than or equal to k. Okay. That means whatever elements we have been given, that we need to distribute this array into arrays of size 3. So in those arrays of size 3, the difference between any two values should not be greater than or equal to k. Okay. Greater than, sorry, not equal to, it should not be greater than k. It can be less than or equal to k. Okay. So if I just see my example and what we need to return, pardon me for this, I just missed that. We need to return a 2D array containing all the arrays. Okay. So we need to return that division, how we are doing that division. If it is impossible to satisfy the conditions, if we come across any example in which these conditions are not satisfied, then we need to return an empty array. Okay. If there are multiple answers, we can return any of them. So they have specified that there can be more than one possible answers for this. We only need to return any of the possible answer, whatever we feel is which can be done in the given constraints that have been given. The constraints for the problem being size of array, that is the size of array is 10 power 5. Okay. So from these constraints, I can check that probably it's going to be somewhere around O of n or O of n log n kind of a solution. Okay. That is what I can infer from the constraints. All right. And let's see the first example. Okay. 1, 3, 4, 8, 7, 9, 3, 5, 1. So they have distributed this array into 3 separate subarrays. K is given as 2. Okay. That is the difference between maximum and minimum values of the array. Okay. What we can infer from this is that difference between any two elements. Let's say if we have this subarray of size 3. Okay. And if I take the minimum and maximum value of this, and if their difference is less than or equal to k, then I'm pretty sure that any other pair will also have a difference of less than equal to k. Okay. So this is what I can infer from this second one. Okay. And the first one is pretty clear that we cannot repeat the values. Okay. So 1, 1, 3. All right. We have two ones in the above array. So 1, 1, 3. If I take the difference between minimum and maximum, 3 minus 1, that is 2. Okay. So that difference is less than equals to k. Satisfies 3, 4, 5. Again, 5 minus 3 less than equals to 2. Less than equals to k here. So again satisfies 7, 8, 9. This again satisfies. So what I can see from this problem is that let's probably move on to the whiteboard choice. Okay. If I just if I just sort this given array, okay, and I'm just going for a greedy approach here. If I have this array in sorted manner, then I know that the consecutive values will have minimum distance. Let's say the array was 1, 2, 4, 6, 5, 7. This is the array we have. Okay. Now, if I just sort this, this becomes 1, 2, 4, 5, 6, and 7. We need to distribute this Y array into subarrays of size 3. Okay. So greedily, this is the best division I can do. Okay. If the key value is, let's say, 4. Okay. Or if that is 3, let's take 3. Okay. Now, if I would have uh, done this like this, what do you call as 4, 4, and let's take 2, 6, and 7. Let's take this subarray. Okay, 2, 6, and 7. So this doesn't satisfy the condition because 2 minus 7 is 5. Okay, that is greater than 3. Okay. So what I can check is that if the array elements are sorted, then automatically I'll be having the minimum difference. So if I take the first element, so it will be having the minimum difference with the element in the sorted array. In the sorted array, the two elements beyond this, that is 4. Okay. So this is the best answer we can have for 1. Okay. We cannot have any minimum value than this. Okay. If you replace 4 by 5, 6, or 7, you see we'll violate those conditions. Okay. So there is the minimum difference that one can get from any other element. So what I'll do is greedily I'll sort my array and I'll check if this division is possible. This, okay, if we add more elements like this, if this division would be satisfied or not. Because if this doesn't satisfy, that means that we cannot have the final answer. Okay. Because this is the easiest answer we can get. All right. So yeah, that'll what we'll be doing. I'll sort this given array, or I'll just run a for loop. Okay. I need to divide this in sizes of 3. Also, firstly, I need to check if the size of my array, if that is divisible by 3 or not. If it is not, that if it is not, that means that the division won't be possible in any case, because in either ways we'll be having some remaining elements which we cannot add to any array. Let's say if the number of elements of the array were 8, so we can have 3 plus 3 plus 2. Okay, 2 is again left because we cannot have a array of size 2. So we need to get another element here, which is not possible. So yes, we'll be checking that. Okay, now in the for loop, I'll just do this division. I is less than m. What I'll do is I'll do I plus equals to 3. Why I'm doing 3? Because I know the divisions I'm doing. I'll just pick up this element, then I want to have this element. Okay, I'll check these 3 elements in this condition. Because it is sorted, so of course, for this value, I plus 2, this will either ways will be greater than ith value. It will either be greater than this value or it will be equal to this value. That is pretty sure. That we are pretty sure of. Okay. So I can just check if I plus 2, that is nums of I plus 2 minus nums of I. If this value is less than equal to k, then I can have the division. So I'll push it to my final result. Okay. This particular set of 3 elements. Okay. Or else I have to return the empty answer. Okay, I'll have to return the empty array, which is an array, so this will be square brackets. Okay, this is what we need to do. Again, spare me on my writing, I'll be improving this in the future. So yeah, this is how we'll be going forward. All right. And I'll just walk you through the code once, then we can probably head back to it if you still have a problem. All right. So what I'm doing is I'm creating a variable n, which is the size of my array, given array. Next, what I'm doing is I'm declaring a result vector. Okay, 2D result vector. Firstly, I'm checking if n modulus 3. If this is not equals to 0, then I just need to return an empty value, empty array. Okay, empty 2D array. In fact, I'll just sort my values now as mentioned in the approach. Okay, and I'll just iterate over my array now. I is equals to 0, I is less than n, I plus equals to 3. Because as I mentioned, that we'll go in steps of 3. Okay. because we need to check these three values, then the next three values, then the next three values like this. Okay. So if I'm here, then I'll have to check from this in the next step. Okay. Because these three values come under a common umbrella. Okay. All these values like this we are going. Okay. Okay. Yeah. Now again, the conditions. We know that nums I is less than equals to nums I plus 2. If you want, you can remove this condition as well. Okay. All I need to check is if nums I plus 2 minus nums I, if this is less than equals to k. Okay. If this is less than equals to k, then I've created a vector near x. Okay. This is my 1D vector that I need to push in the result vector. So I'll just push nums I plus 1, I plus 2 to it. And then I'll push this x vector to my result vector. And after that, I've added a continuous statement. This is again optional. If you want to remove this, you can remove this. Okay. Else, what we need to do? Else, if this condition doesn't satisfy, if this condition doesn't hold true, then we know that these three values cannot be grouped with any other values. So I'll simply return false in that case. Or false, or in this question, they have asked us to return an empty 2D vector. So I'll just simply return this empty 2D vector. That's it. And when I come out of the loop, then all my conditions would have been satisfied. So I can simply just return my result vector. Okay. Result 2D vector. That's all we have for this question. The complexity for this question, let's see. Firstly, we were doing a sorting operation. Okay. We had a sorting. Let me just change the color. Yeah. Yes, we have a sort operation. Then we iterate over the 1D array. Okay. And yeah, these are the two operations. So the complexity for this is n log n, and for this is n. Okay. So the worst case complexity becomes O of n log n. As I mentioned in the beginning, that the complexity for this code, that will be somewhere, it will either be a O of n approach or a n log n approach. All right. Now let's just move on to the third problem. Okay. I just try to improve my handwriting in this one. All right. So this was a very, I would say, fussy kind of a problem. It's more of an observation-based problem, and you will get these kind of problems. You'll be able to make these problems when you practice a lot. Okay. So let's go to the problem statement. We have been given a zero index integer array nums having length n. You are allowed to perform a special move any number of times. Okay, we have been given a 1D array and an operation. Let's see what we can do in this operation. We can choose an index I in the range 0 to n minus 1. That is the range of the array indexes, nums array indexes, and a positive integer x. Okay, so we can choose any index and any integer x we want. Add nums of I minus x to the total cost. Okay, so this means we'll have to create a cost variable here, and we have to add this cost. Now, after adding this cost, what does this cost give us? Okay, let's see that in a third point. So after adding this cost, we can change the value of nums I to x. Okay. So they want us to change the value of nums of I to x. Okay, this is the operation we can perform, that we change the value of any index of the array to some value we want. And then we need to add this much cost to our final cost for this operation. This much cost. Okay, absolute value of nums of I minus x. This is what we need to add. A palindromic number. Okay, they have given a definition. Palindromic number is a positive integer that remains the same and the digits are reversed. Okay. So palindromic number is just a palindrome in form of a number. Okay. An array is considered what is this term? Equalindromic. Okay. If all the elements in the array are equal to an integer y, where y is the palindromic number less than 10 power 9. Okay. An array is considered equalindromic if all the elements of the array are equal to an integer y, where y is a palindromic number less than 10 power 9. Okay, so we need to change the given array into an array where all the elements are equal and they are equal to some value y, and y is a palindromic number itself. This is what we need to do. Okay, return an integer denoting the minimum possible cost to make the array nums equalindromic by performing any number of special rules. Okay. So we need to reduce the number of the total cost for all these operations. So we need to have this equalindromic array from this given array we have been given, and the cost should be minimum. Okay, the total cost we do for that for changing this given array, that should be minimum. Let's take an example for this. So we have, if we have the given array 1, 2, 3, 4, 5. Okay, so in the example, they have given that we can change the array to 3, 3, 3, 3, 3. Okay, that means we replace all the values by 3. And the total cost we incur after doing this change is 6. So this is the minimum possible cost. This is what they are saying. Now, from the second example, what I can see is that 10, 11, 13, 14, 15. Okay, they have taken the element to be 11. Okay, in this case, 11 would be the element which will give us this minimum cost, and the cost will also be 11 if you calculate it. And in the third example, similarly, we have 22. So if we replace all the elements by 22, we'll be getting a minimum cost that is itself 22. So this is more of an observation-based questions. For me, this took a long time to understand how things are working here. Okay. What I observed, what my observations were when I saw the third example, I could see first as a third example, when I saw that, I could see 22, 22, 22, 33, 33. Okay. This somewhat gives me an idea of a median. Okay. That if I take the median of this array, that is 22, and if I just replace all the elements by this can give me the best answer. All right. But there was another case, that was the second example, which was a bit difficult to get. Okay. 10, 12, 13, 14, 15. The first example is also based on the median based approach. Okay. The only problem was with the second example, what I could see. All right. 10, 12, 13, 14, 15. All right. Let's move on to the whiteboard. 10, 12, 13, 14, 15. Median for this is 13. But 13 is not the possible answer because 13 itself is not a palindromic number. So what I could have done was, what I said that maybe I should check all the values less than 13 in general. 12, 11, like this, 10. And whatever the first value I get as a palindrome, that is 11, that can be my possible answer. And similarly would be the case for values greater than 13. So that it is 14, 15, 16, 17, 18, 19, 20. So you will go till 22, and 22 will be the first palindromic number. Okay. So whatever on the LHS and the RHS of the median, I'll just pick up the closest palindromic value and I'll check what will be my answer for both these values. The one which gives me the minimum cost will be the answer. So in this case, if you see 11 will give you a better answer, it will give you a lesser cost as compared to 22. So 11 would be the final answer. Of course, you need to return the cost as well. So you'll return the cost in this case, but the element would be 11. Sure. Okay. So yeah, that'll be it. And okay, so again, I'll just move on to a new page to just describe how we'll be coding this. Okay. So firstly, we'll sort the array. You sort the array. Next, what we do is we need to pick the median. So for an even array, okay. So this is an odd one. Okay. So for an odd array, we have the median as n by 2. Let's replace nums by x, okay? Just because I want to have a shorter name. And n by 2 plus 1, all right, by 2. This will be my median, okay? And for an even array, the median is n by 2th element, okay? This is what we have. So this is how we have our median now, okay? Now, greedily, if I know if this median is only, if this median is a palindrome, if you just check this, then of course this will be my best answer. why would I go for any values less than or greater than if this is only a palindrome? So if the median is a palindrome, you just check the cost for this median and that will be the minimum cost. Just think about it once, okay? This question is more of mathematics and observation. So yeah, again, there's not a lot of data structures you can involve into this or algorithms. This is more of a mathematics question. So we have this case. Next, I check if the median is not a palindrome. Then I go for all the values less than median. And let's say I stop at a value y, which is a palindrome. Okay, so I'll have this value. And similarly, on the RHS, let's say I have a value z, which is a palindrome. So I'll just have both these values. Okay, and I'll check the cost for each of them. Cost y, cost z. Okay, I have the cost for both of them, and whichever gives me a minimum cost, I'll just return that value. Okay, if that is the case, because see, if they are given us another question, another condition, okay, that is that the palindromic number should be less than 10 power 9. Okay, and they have also given that all the elements are in the range 1 to 10 power 9. So we need to follow these constraints as well. Okay, that is, we cannot have a value on the lesser side. We cannot have a value less than 1. Okay, less than 1. Okay, so y is always greater than equal to 1. Similarly, z is always less than equal to 10 power 9 because they have given that. Okay, so if that is the case, that you get y is equals to 0. Although that won't be the case because you will always have any integer like 9, 8, 7. So this will automatically satisfy your answer. Similarly for the RHS. Okay, so if you come across any case on LHS where y is less than 1, so you just return the answer of the this side. Okay. And similarly, if you go to any value z greater than 10 power 9, so you just return the answer for this case. Okay. That is how we'll be doing this question. It's a bit difficult to do because this is more of a observation based question. So for in the contest duration, I think that this will take up a lot of time. Okay. So although in my case, it was advisable that move on to the fourth problem instead of solving this, because today the fourth problem was easier as compared to the third one. That's what I felt. Okay. So we have this case and let's just quickly just discuss this complexity for this. Okay. So we are again checking the palindrome. You have maximum 10 power 9. So that is, if you take it as a string, that is 10 digits. So that will be a constant uh, time complexity. Checking it in the best worst case scenario, a string of length 10, whether it's a palindrome or not. So that won't incur a lot of complexity. The only complexity, the major contribution will be through the sorting. Okay, n log n, and this is what will be the worst case complexity of this code. Okay, okay, worst case complexity will be n log n. If you can just check this code. Okay, so yeah, let's move on quickly. Just move on to the last problem. So this was a good problem, but still easier than what we get usually. Okay. So we have been given a zero index integer array nums and an integer k. You can perform the following operation on the array at most k times. Okay. Choose any index I for the array and increase or decrease nums of I by 1. Okay. So we have been given k operations. In every operation, you can select any element and we can either decrease or increase its value by 1. The score of the final array is the frequency of the most frequent element in the array. Okay. So after the operations, the values of the elements will change, and we need to return the frequency of that element uh, which has the maximum frequency. So we need to return the maximum frequency of any element. The element does not matter. The maximum frequency is what matters here. And what we need to do is we need to maximize the score. That means we need to maximize the frequency of a single element in the array. This is our task. Okay. So if you see again, if you see the constraints for getting an idea of this question, we have maybe initially I thought when I just read the question that there will be the value of k will be less than 10 power 5. But when you see this as 10 power 40, then you know that you cannot apply these operations greenly. Okay. So what you will have to do is that you'll have to think it from the array perspective. You cannot directly use this value in a loop because this is 10 power 14 already. Okay. Now, what I can say is that if you just make an observation that the maximum frequency can be between 1 to n. It cannot have any value greater than n, or it cannot have any value less than 1. Okay. So it's gonna be between 1 to n. So we have the range of our answer. We just need to check if the best answer is possible. So when we have the range and there's a limited range we have, and we just need to pick based on some conditions whether that value is achievable or not. So what do we go for? We go for binary search in this case. Okay, that's how you uh, boil down to this approach of binary search. Okay, so I'll just quickly move on to a new page. This will be my last problem for this contest, problem 4. All right, and the approach for this is binary search. Okay. Now, what do I do in this case? Okay. Acha, just think about it. When you're applying binary search, so it's very obvious that the array needs to be sorted. So the first step, of course, would be to just sort the array, sort the given array. Okay. First step, we are done. All right. Next, what do I need to check? I have the range of values for the answer. The value will be between 1 to n. Pretty sure about that. Okay. All right. And so if we have the sorted array, and if we want to, what was the operation given to us that you need to change the values? You need to change the values by either decrease them by 1 or increase them by 1. Okay. So let's say if my answer is x from this range. Okay. Let's say x is 4. Assume the case. Okay. So, and if I want to change the values somewhere, okay. Let's say this is where I want to change my value. So I'm pretty sure that greedily all those values will be consecutives. Okay. Let's say if I want to, let's just take an example for this. This cannot be explained in general terms. So let's just take an example. 1264 k is equals to 3. Okay. 1264 k is equals to 3. Okay. So the array is given to us. The array is 1264. Sorting this, we'll get 1246. Okay. Now, and the operations we have is 3, maximum number of operations. All right. What we can do from this is that, let's say if I have x equals to 3, just assume x is equals to 3. So if I want to change my values, so I'll do that for all the subarrays of size 3 only. No, I cannot do it like this 1, 2, 6. If I just do this, this is not a better case I am having. Okay. Ideally, what I'll do is I'd like to save my operations as much as I can. Okay. So I'll do that for consecutive elements because I know if I do 4 minus 2, I'll get 2 operations. And if I do 6 minus 2, that will be 4 operations, no? So I need to do this thing for consecutive elements, right? So that I can save my operations as much as I can, and so that all the operations can be applied. Okay, we want to save our operations because we do not want if I just pick 1, 2, 6. So and this takes 4 values, like reducing 6 to 2 will take 4 operations, and I cannot change 1 in that case. Okay, so I do it for 4. I'll to apply 2 operations here, and I'll apply 1 operation here, and this will be 2, 2, 2. The frequency would become 3 for 2, and this will be my best answer. All right, this is what we need to check. That we need to check it for all the consecutive arrays, all the sub arrays of size x. Okay, so by binary search, let's say if my middle element is equals to start plus end minus start by 2. Okay, this is my middle element, middle answer, or this can also be said as the frequency. So I need to check on all the subarrays of size x, subarrays of size x. I need to check whether all the elements of those subarrays, if for any one of them, all the elements can be made same, okay, in operations less than or equal to k. Okay, this is what I need to check. And which element I'll be checking? If I just take this example again, 1, 2, 4, 6. All right. So if that is an odd size of array, this will be the best case in a sorted array. If you want to apply these kind of operations, apply it on the middle element. Okay. This will always give you the least answer. This is again a lot of observation. So just observe this, that if you apply it for 4, you will get you'll have to make greater number of operations. Similarly, if you apply it for 1, you will have to make greater number of operations. But if you apply it on a middle element, then you will have to make lesser operations. Okay. Now, if the size of the array is even, let's say if it is anything like this, 1, 2, 4, 6. So you will have to apply it on the two middle elements, that is 2 and 4. And which one of them, whichever one of them will give you the this thing, case submitted, you will just have that case. Whichever one of them gives you operations less than equals to k, you can have that case. Okay, that's up to you. So this is how we'll be doing. I'll just quickly summarize on the new page. We'll firstly do a binary search. Okay, from 1 to n. We pick a middle value, start plus end by 2. We check if it is possible for for any subarray of size m, if it is possible to have less than equals to operation number of operations, if that is possible. So I'll update my answer variable. Answer initially would be 1, because in any case you'll be getting 1 as the answer. That is for sure, that at least the frequency of every element is 1. So 1 will always be the answer. The answer cannot go below 1. Okay. So even if you want, you can start this from 2 directly. That is what I have done in my code. So I'll just update my answer and then try to get a better answer. So I'll update the start variable to m plus 1. Okay. Else, what I'll do is if that is not possible, if this is false, okay, then what we are doing is we are not updating the answer in this case. We are just updating the end variable, because we know if n is not possible, so we'll have to check for values less than n. So I'll update my end variable and I'll just return the answer outside the loop. This is what we'll be doing. All right. Now just let's head over to the code once. Enough discussions for this one. Okay. This took some time to code, but chalo, anyways, it was still not a very, I would say, as difficult problem. So this is what I've done. I've just sorted the array and as the size of the array. S variable, the starting of binary search, I've taken as 2, because I know the answer will be 1 in the worst case possibility. I'll always get 1 as the answer. So I can start it from 2 and we go from 2 till n. Okay. I check it for a middle value, middle n, that if it is possible. How I am checking that? I've created a separate function. Let's just see this function once. Okay. So I've done a prefix case here. Okay. I've stored a prefix array for the sum. Okay. Because we need to count the number of operations. Now the next steps, this would involve a lot of mathematics again. So if the size of the array is odd, we discussed that there will be only one middle element. The index for that element will be I plus x by 2. Okay. Think about this. Once. Let's if you are starting from index I and you are going from I plus x minus 1. Okay. And this is an odd size array. So the middle index will be I plus x by 2. Think about this. Like if I was 0 and the size was 3. So the middle index would be 0, 1, 2. So index should be 1. Okay. So 0 plus 3 upon 2. This is 1 if I take it as an integer. Okay. So 1 would be my middle element. All right. This is what I'm doing here. Okay. There is some mathematics. I will try my best to explain this. Okay. And now I'm taking the operations. Okay. So we have the left side of operations and we have the right side of operations. Okay. So just a moment. Yes. Let's move on to a new page now. Okay. So if I have this as a middle element, okay, I plus x by 2 and I plus x minus 1. So how many operations do I need to apply? For all these elements, I know it's already sorted, so it will be less than that. Okay. So I'll have to take the prefix of this, okay, prefix of this underlined part, okay. And what will be the number of elements of this? Okay. this will be x by 2 minus 1. Okay. Think about this. Okay. This is the middle element. If the size of the atom is 5, odd size, so we have 5. So middle element x by 2. No, it will be x by 2 only, not x by 2 minus 1 because that's an integer. So it's x by 2. Okay. So x by 2 on the left hand side, we have x by 2 into multiplied by this element, middle element. Okay. Element minus prefix of this part, which I have highlighted. So this is the number of operations on the left hand side. Okay. And the number of operations on the right hand side, okay, that we need to count. So how many elements we have? Okay, x by 2, we are done, x by 2 plus 1. So we need not take this part, that is x by 2 plus 1 elements. So how many are left? I think x by 2 minus 1. This is the number of elements left, okay? All right. And multiplied by element, okay? But this time you see, if this is suffix, let's say suffix, this suffix will be greater than this element, middle element. Okay, this will be greater than this element. So I'll have to add a minus here. So I'll do suffix minus this part we have, okay? This x by 2 minus 1 into element, okay? So this is how we'll be doing that. This is the number of operations. And let's say this is A and this is B. And I'll check if A plus B is less than equal to K. If it is, I just return true, okay? Else I'll return false, okay? Similarly, you can generalize this kind of thing for the even size of array. So this is what I've done, okay? If the size of the array is odd, all right, I can just simply, what do you call as, just take the middle element, A, that is the left side of operations, and B, that is the right side of operations, all right? And in fact, I think I have had B as the, just there's a name in the change in the variable name. So I've taken B as the left side and A as the right side. So you can just check this, see what these values are. Think about this, write it on a pen and a paper, you will be good to go. And if this is less than equals to K, I just return true. Now let's move on to the case for even numbers. If X is equals to 2, so I've just handled this separately, so we do not have to go into a lot of mathematics because this was throwing some errors initially. So this absolute value of, because if we have a size of array 2, so I know that is only 2 elements, I and I plus 1. So the number of operations for them would be nums of I minus nums of I plus 1, absolute value of that. If you just take the absolute difference of that, and if that is less than equals to K, you just return true. Next, for the case, if the even number is greater than 2, again, you have to pick two middle elements. So the first one will be I plus x by 2. This is the first middle element, right? And the second one will be the element just before this, that is element minus minus. I plus x by 2 minus 1, right? Similarly, you have the operations on the left and right hand side for both of them, okay? Count the left and right hand side operations. Check for each of them if the sum of these observations and operations is less than equals to K. If it is, return true. And if it is not, you'll just come out of the loop, okay? You'll just come out of all these conditions and you'll just return false. That it is not possible to have a sub-array of size X with the number of operations less than equals to K. Okay, so you just return false in this case. Now, if you just once, let's submit this code for once. This is accepted. Okay. Same was the case with the previous codes as well. Okay. If you just accept this, if you just submit this, it will get accepted. So that's all we are doing here. Okay. And okay, I think it's taking some time. Yeah, it's accepted now. All right. So this was all just to highlight the complexity for this last one. Okay. The complexity of this last code will be again n log n. Simple as that, because we are doing binary search plus a for loop, okay, for checking the operations, okay. So n and log n, okay, and both of these things are nested with each other, so it will make n into log n, okay. So yes, this will be our complete code, and when this finishes the discussion for this particular contest, I hope you enjoyed it. Please feel free to leave your comments, any feedbacks you have in the comment section. I'll be happy to improve this in future videos. And Well, let's meet in the next bi-weekly contest. Happy learning, enjoy DSA, and yeah, good luck. Bye bye, everyone.